Namaskar. Welcome to Prakash on Basics. I'm Prakash Zog. From today, for a few days, I would be discussing out one of the most important energy forms that we know of. Obviously, that's electricity. There are many reasons why it is very important. Please realize that electrical energy is not the earliest form of energy that arose after the Big Bang. Actually, after the Big Bang, what started off was heat resulting into temperature. Then there was formation of electrons as matter started getting formed, and it resulted into quarks, antiquarks, then nucleons, that is some of the basic particles, then helium, hydrogen, and then arose the possibility of electricity with the formation of what is known as the grand unified force, which resulted into the electromagnetic force. I know quite a bit of complicated words that I've used, but I'll go into details of all this when I start talking of the Big Bang. Right now, just understand that this is the way it really worked out in the beginning. And what about humans? For humans, the lightning that the humans saw in the sky was their first interaction with electricity. Then came static electricity quite a few centuries back. Then came direct current that was stored in batteries and cells. And we have so many different forms that we have today. I'll go into details of all of them as I move further. And then, say about 150 years ago, we had the second industrial revolution. And at the heart of this revolution was nothing but electricity. As of today, it is the most important form of energy that we know of. But there is one more, probably more important reason, probably the most important one. Our human body works on electricity, something that many of us don't even realize. Our brain, our heart, our muscles, whether they are voluntary muscles or involuntary muscles, all our sense organs, all the living functions that we do are all based on electricity. How? I'll come to some time later. Please realize that um, electrical impulses within our body can be recorded in the form of a variety of waves. And when we study these waves, we get information related to our health or of not being in good health. We've heard of words like ECG, EEG, electroencephalogram, and MRIs, and PET scans, and a variety of monitors that we see that are attached to human beings. They all work on electricity and are informers of what is happening within our body. And then we have so many other instruments, the dialysis instrument, the heart lung machine, every equipment that you see in the ICU is basically associated with electricity. And then even things like lie detectors, which are associated with what is known as the skin galvanic resistance, and so forth. There's so many applications with so many variety of machines that are attached to human beings that give information about human beings, whether they want it or not. All instruments that enhance the capabilities of our sense organs are also based on electricity. It could be a very complicated set of things like the electron microscope that tells us about the atomic and the molecular structures, or radio telescopes that give us information about space and far off objects, and right up to very small objects like our hearing aids that are around. And what about knowledge? All storage of knowledge, whether it is in computers in the form of semiconductors or ICs, all these work on electricity. No electricity and nothing of this would exist. And one more major issue associated with electricity is that it can be converted in all other forms of energies. It could be direct, like piezoelectric effect, or it could be in steps. Um, for example, if I talk of something like a TV, when I switch on a TV or a monitor of this sort, we realize that light comes out of it, so there is light energy. A TV gets hot, so there is heat energy. It is associated with magnets that are inside, which are enhanced because they are electromagnets, so it works with magnetism. It is associated with emission of electrons, which is nothing but beta radiation. And so you would find that we have sound and everything else that comes out from electricity which enters the TV. And it could be something like a bulb, the old ones that we have been using. It first gets hot, so it means heat energy, and then it starts giving out light, which is light energy. And so you would find that electricity can be converted very conveniently into a number of different objects, different energy sources. Uh, we have ultrasound that is used, that is again sound energy, and we have lasers, which is associated with light energy, and so forth. Um, Also, realize that electrical energy can be obtained from all other energy sources quite conveniently. Uh, we know that all known energy forms uh, are used in one form or the other to obtain the electricity that is around us. Uh, it could be something very simple, which I'm going to come to, which is like a gas lighter, in which mechanical energy is directly converted into electricity. Or it could be directly sunlight, where you have solar panels that nowadays produce electricity directly. And then heat energy is one of the major sources that we have used to produce electricity in the form of those hydel plants that we have. And nuclear energy and wind energy and sound energy, all these are finally linked to the same process of producing electricity through the same mechanism, which I'm going to explain a little bit. The reverse is also true. Uh, Electricity can be obtained from machines like generators, and these can be finally linked, as I told you long back, to the sun. Finally, heat energy, whether it is in the form of nuclear energy or any other form, finally results into turbines that move. Hydel plants have the same turbines that move, and all that results into energy generated by what we typically call as generators. And remember the dynamos that you had attached to cycles that produced electricity. And nowadays we have those gensets where they are all the same. They all produce electricity from a variety of fuels. And then there is one more important issue associated with electricity. Electricity can be transported globally through cables, and very fast, very efficient, with very little loss, and right from the point of production, that is the generator, to the point where it is put to use, which could be thousands of kilometers away. And in the process, there's hardly any loss. Reasons I'll come to sometime later on, but realize that transporting all that coal to your house and using it, or getting firewood and using it, is all very complicated and difficult. Electricity has simplified a lot of things for us. And of course, it's pollution free. There's no carbon footprint associated with electricity. There are some misuses which lead to carbon emissions, but basically, electricity does not contribute in any way to carbon emissions or any other harmful gas emissions. There are quite a few other advantages also. Realize that electricity is a tool that can be controlled very precisely because of the ingenuity of human beings. We can control the power output to a minimum value, uh, in microvolts, or which is used in a variety of semiconducting chips, integrated circuits as they are known. Or it could be up to about 1.5 volts, etc., which is used in the cells that we commonly talk of. or it could be a little smaller at a very slow rate for a long time, like things like a pacemaker that is fitted inside. How it works, I'll come to some time later. Or it could be a situation where gigawatts of power is utilized. It's used in ships to drive ships, but I think they run on diesel. And what about the locomotives? They are also said to be electric trains, to we all know of. But please realize that when we talk of diesel engines or diesel locomotives, they are actually diesel electric units. Same thing happens many times in these modern ships also. There are diesel engines inside that are connected to generators that generate electricity, which is used to drive the engines, either major ships or all diesel electric engines that we know of that are used for railways. Then there is one major issue. There are two energy forms, magnetism and electricity. And the interdependence of electricity and magnetism was realized by the scientists around 1880s, 1860s, etc. And that changed everything. They realized that moving charges, and moving charges is nothing but current. So current produces magnetic field or a region in which magnetic quantities can change. And the reverse is also true. So if you change magnetic fields and place a conductor in it, electricity begins to flow through the conductor. And this is known as the magnetic effect of electric current. So current produces magnetism, and a changing magnetic field or flux produces current. And this is the crux of very important equations. You know, people, when people are asked about equations, everybody talks of E equal to mc squared, and that is an equation that everybody seems to know, including t-shirts which have markings of. But that's not something that we use in day-to-day life every day. It's a hyped up equation as far as we are concerned, as far as practical issues are concerned. The one that's truly important is the one, if you can notice, that's there behind. Uh, it talks of a relation between force, a conductor carrying current, and the magnetic field intensity, which is F equal to IL cross B, where I is the current, L is the length of the conductor, B is the strength of the magnetic field that is around, and F is the force. It can be simplified mathematically to F equal to ILB sine theta. And these are things that are at right angles to each other, like this. And that's why that diagram that you can see behind. So if the force is along one particular direction and the current is along one particular direction, the magnetic field is along the third direction. And if you have two of them, you can produce a third one. So if I have a current carrying conductor placed in a magnetic field, a force will be developed. And that's exactly what happens in a generator. So there is a coil that begins to move in a magnetic field, and this results into two possibilities. If you provide the current, you have the force that is developed, and that is typically referred to as the motor. And that's what happens in the fan that we use. And all the motors that are around us work on the same principle. So you pass current in a coil that is in a magnetic field, and there is a force developed which is used to rotate it, and that's a motor. And you do the reverse. That means you start turning this coil in a magnetic field, and a current begins to flow in that coil, and that's a generator or a dynamo that we talk about. This equation originally um, was associated with a person called Lorentz. He put the equation in a slightly different form. He talked of a charge moving at a velocity v in a magnetic field, producing a certain amount of force. And this is known as the Lorentz force. Actually, that can be modified into the other equation F equal to IL cross B. I know I'm talking of equations, not required. I've already told you what motors and generators are. And if you know that, I think that's good enough. Because all around us, the two most important machines that are around us are generators and motors. Look around you and you will find that they are there everywhere, right from the windmills that are used to generate electricity to every vehicle that moves around that works on electricity. Everything is associated either with a motor or a generator. Around 1865, um, there was a person called Maxwell, a scientist called Maxwell. He put up a certain set of equations that correlated all this information. And around 1895 is the time when Lorentz put up the equation that I just talked of, QV cross B, giving us F, the force. Sorry, cross means a special way of multiplying. It's known as vector product. Just it's as good as multiplication as far as we are concerned. And then there were people like Laplace and Fleming and Faraday. And these are the people who worked on all these equations and correlated equations with electricity, magnetism, and chemicals, and brought about the big change that we have all around us. Force, movement, magnetic field, all put together. If two of them are present, the third one can be produced. And that is at the core of practically everything associated with electricity that we know of. So that electricity and magnetism link is probably one of the most important links. Then there is one more aspect that we must be kept in mind. I'll go into details of atomic structure sometime. But I'm sure from your schoolwork and whatever we read, generally we are aware that we have atoms and we have electrons going around. Basically, they are neutral. And if you pull out one of the electrons, what remains is typically referred to as an ion, and it has a positive charge. And if an electron is removed, that electron has a negative charge. And you apply certain amount of voltage, these electrons begin to move in one direction and the ions begin to move in the other direction and so forth. Another issue with this is as soon as you remove the electron, what is left is the ion. And that scientifically is treated as a chemical change. And electricity can do that. By applying certain amount of voltages, which I will define a little later, you can remove those electrons and convert a normal atom into ions. And if electricity can do that, it can result into a chemical change. So, chemical energy was the first form of energy that was successfully used to produce electricity. It's a very interesting story. It's about a guy called Galvani who was working. They believed that life was a force, life force. When a person died, that force used to disappear and so forth. Many different ideas. And this fellow was working on frogs' legs. And these used to be preserved in certain chemicals. And it was lying on a metal dish. And the instant the frog leg, naturally it was dead. The instant he touched it with a metal probe to dissect it and so forth, the leg began to twitch. And he had a feeling that probably there's some life left in it. And that's the time when they realized that there's some association with the chemicals that are used and the two metals that are being used, resulting into certain electricity that is causing that leg to twitch. See how science begins and triggers on. And from there came time when these cells were produced. the voltaic cell and the Leclanché cell and so forth. The dry cell is more important, is the one that we used in our childhood, containing a zinc casing with a rod in the middle, which was made out of carbon and some chemicals inside, ammonium chloride and so forth. Um, so a cell that we know of. And that produced an electricity that we know of, which is known as direct current, because the direction of flow of the current is only in one way. And these cells, and the common word that we often hear is battery. A battery is a word actually from English. It talks of a set of guns firing in the same direction. So, a number of cells sending current in the same direction is known as a battery. So, what you have in a car is a set of about six cells connected to each other, sending current in the same direction, and that's what forms a car battery. So, that's how batteries work. And energy is stored in the form of chemical energy within the cell or the battery, and it results into a flow of current outside. But then, as I said, everything was reversible, and so it was possible to reverse the direction of current, electricity, and cause the chemical reaction to go backwards and store that energy back again in the form of chemicals within the battery itself or the cell itself. And this resulted into what we typically know as rechargeable cells. They started off with lead acid batteries, but nowadays we have so many different rechargeable batteries. If some of you all remember, there was what was known as Cadnica or nickel cadmium type of rechargeable batteries long back, about 50, 60 years back. And then there were, before that, there were what was known as knife or NIFE, that is nickel and iron. And nowadays we have the lithium ion batteries, which are the most popular ones. And just prior to it, we had what are known as the mercury halide batteries and the silver halide batteries and so forth. These are the ones that were used in cameras and other places. And we have similar batteries even in the pacemaker that is fitted inside. So these chemical changes resulting into electricity was an important issue again. So electricity can go in that form also. And then we had uh, concentrations of acids that were used, resulting into flow of current and so forth. So these were the cells that were used to produce electricity. There was one more issue. I told you that removing an electron results into a chemical change. And this was studied by a person called Michael Faraday. And what he did was he found that he could bring about certain chemical changes by passing electricity through liquids that could get ionized. And this process was known as electrolysis. And Michael Faraday came up with a number of laws of electrolysis. Let's not bother about them. What's more important is what happens because of it. And the most important thing is that you put two electrodes in a slightly acidic water and pass current through it, and what you get, wow, is oxygen and hydrogen that gets separated out. In COVID, oxygen was obtained, which was required and stored, was all obtained by electrolysis at different places. Electrolysis is a very common practice. You could do it to a metal that is heated up or a salt that is heated. Actually, our own salt that we know of, which is sodium chloride. And when you have molten sodium chloride and you pass current through it, what you get is sodium metal separated out and chlorine gas, which is industrially one of the most important gases that is required, forming a number of variety of acids. So this is what electrolysis can do. That's not all. Metals can be refined by using electrolysis. Protective coatings, uh, chromium platings, etc., can be done. Electroplating that we know of, either of gold or silver or other materials on base metals like copper, etc., can be done by using this technique of converting electricity into chemistry in a different form. And that is electroplating. And there is a possibility of a combination of two or three of them, which all of us know and see around us. It is that arc welding that we see people doing. And arc welding is nothing but using extremely large amount of current to vaporize metals and cause a deposit. In the process, there is a huge amount of heat that is generated. You can see an extremely bright light that is being produced, and there is a chemical change which deposits, converts them into ions and deposits them, forming a new joint and a perfect weld at a given point. Ships are built by using arc welding of this sort. And heat, obviously, heat is the basis which is of all those thermal power plants that generate electricity. I'll go into details of that sometime later, but there's one more effect that we must know of. It is possible to convert directly heat energy into electrical energy and vice versa, and this effect is typically referred to as thermoelectric effect. There were two people who worked on it. One was Seebeck. What he did was he took two metals of different types, joined them, and heated one junction of the metals and cooled the other one. And he found that current began to flow. A very simple technique to remember it is antimony to bismuth at the cold junction is the type of current that flows. So naturally the opposite at the other end. And this was known as a thermocouple. How it is used, I'll come to sometime later. And naturally, the reverse was also true. That means if you took two different metals and passed current through it, then naturally one junction would get hot and the other junction would start getting cold. And that was the reverse of this particular effect, which was discovered and studied to a large extent by a person called Peltier. And so it is known as the Peltier effect. There's one more Thomson effect, but that's a little complicated. So let's not talk of that just now. Is there anything else? Yes, definitely. Um, all of us use a gas lighter at home. And what do? You apply a little bit of pressure and there is a spark that is produced. And that effect is known as piezoelectricity. There are certain crystals, tipped ceramics, etc. Some of the basic one is quartz. And if you cut it in a specific manner, I won't go into details, but there are a number of faces that can be produced. Any cube or any structure of this sort that is produced usually has six faces. And under given conditions, under given way, manner in which it is sliced, two things can happen. There is mechanical force that is applied across two faces, results into a very large amount of charge being developed momentarily across the remaining two faces. And this, if connected, results into a spark. So that's exactly what you do. You just press a knob and it gives you an impact on a crystal inside. And so the impact results into a very sharp amount of set of charges being developed, which result into a spark which ignites the gas. And the effect is naturally reversible. So if you do the reverse, that you start applying voltage to two ends, then two sides begin to vibrate. And remember what we did in acoustics? We talked of acoustics in which the maximum frequency that we can hear and produce is around 20,000 hertz. But for so many other equations or requirements like ultrasonics, what you need is much higher amount of frequencies. So what you do is you use an oscillator and apply maybe 30, 40,000 hertz frequency to two sides of a crystal. And the other two sides begin to vibrate. And if they vibrate, they are going to produce sound energy. And that's how ultrasonic sound is produced. So ultrasonic sound generators are produced because of this particular effect, which is piezoelectricity. That's not all. It's very interesting. Remember, people have quartz watches, and so they tend to oscillate. A quartz is a crystal that is piezoelectric. So if you apply a suitable set of voltages, it will begin to oscillate at its natural frequency. And it's a very large number of the order of natural frequency is around 32,728 hertz. That's pretty big. It can go wrong by how much? By standard rules, it can go wrong by only one, plus one or minus one. And in that particular case, what it implies is out of so many, there's only one error that is possible. So if you can connect it to counting systems, which I'll come to sometime later, It's possible to get a watch that can measure time extremely accurately. That's what a quartz crystal watch is. So you'll find that there are so many applications that we have around us. And the other major one is obviously light. Solar cells is something that we know of. So when you have light falling and you want electricity, you use a solar cell. And the reverse is also true. You put light, and what you get is it's possible to reverse the process in which you can generate an electric current by using what is typically referred to as a photocell. And I talked of E equal to mc squared, a famous equation by Einstein. And people believe, quite a few people know that he got a Nobel Prize. But what he got a Nobel Prize was studying this photoelectric effect and its interpretations. So that's where Einstein got his Nobel Prize for. So photoelectric effect is an extremely important process. And all these, where you go and wash your hands and the water flows, and the instant you remove your hands, the water stops. And all this is controlled by what are known as photocells. There's so many applications of photocells of this sort. Um, Semiconductors can be used to produce laser light. And these are all those light torches, laser torches that you get. They are all semiconducting lasers, and in that, electricity is directly converted into laser beams. Then we have those LED bulbs, light emitting diodes. They are all the same. They all convert direct electricity into light. So you will find that reversibility of light is also something that we know of. And then electricity is all around us, can be produced from the sun, from the wind, from water, from geothermal energy, from nuclear plants. Everywhere we have electricity that is being used everywhere, right from the smallest areas to our electric cars that we have. And it's one of the best sources of energies that we have. This is just the tip of the iceberg. Many of the things that I mentioned are things that we use in our day to day life. So it's quite essential that we know and understand it properly. And for that, you might have to know certain terms that we so often use in electricity. And so we must understand these terms. That's what I will deal with next time. If you have liked whatever I have said, if you have appreciated whatever I have said, please store this information with you. Tell your friends about it. Let them also gain knowledge of the greatest of energies that is around us, the most important one, which is electrical energy. Till I come back with more information on electricity for the next few weeks. Namaskar.